On the method of resolution of forces, you'll be told a particle experiences forces of magnitude 2, 2 root 2, 6, and 8 inclined at an angle of 30 degrees, 45 degrees, 60 degrees, and 120 degrees respectively to a given direction OX, isn't it? Then you'll be told to use the method of resolution of vectors to find the magnitude and direction of the resultant vector. Now, if you want to use the method of resolution of forces or vectors, you resolve a vector into its x and y component. Are we together? You resolve a vector into its x and y component, meaning you form a table with two columns. The column for the x component and the column for the y component. So this is the column for the x component of the vector, and the second column is the column for the y component of the vector. Then you check how many forces here do you have? 1, 2, 3, 4. Meaning you put each row for each force, isn't it? You create a row for each force. A row for each force. So you come and say this is force 1, here is our F2, F3, and the last one F4. Then in the end, we want the resultant X component using the parallelogram law, isn't it? Are we together? Then here, Y component of F1, Y component of F2, Y component of the third force, and Y component of the fourth force. Then in the end, you get the resultant Y component. You add all of them, the parallelogram law, isn't it? Are we together? Yes. So if you look at this, how are you getting the X component? The X from coordinate geometry or complex numbers was given by X was R cos theta, and Y was given by R sin theta. Are we together? And remember, this is force, meaning our R is the force, So this is X component of the force, this is Y component of the force. So you know anytime you are getting X component of the force, it is the force times the cosine of the angle. It makes with the positive X-axis to be seen. So told here the direction is OX, that's the positive X-axis, isn't it? Then the Y component of the force is always the force times the sine of the angle it makes with that positive. The reference must be for everything, meaning the reference OX is for all the forces, isn't it? Are we together? So X component is F cos theta, Y component is F sin theta. Are we together? So move here. Go to the first force. The first force is 2 acting in what direction? 30 degrees. So it means the X component will be 2 cos 30. What do you get? The Y component will be 2 sin 30, isn't it? So if you press 2 cos 30, what will you have? 1.733. 1.732. Then the Y component X sin 30, you get 1. Now the best way to doing that, you simply go to the calculator, meaning when you have 230, remember 2 is R and 30 is theta. R is the force, isn't it? And when you are getting 2 cos 30, you are getting X, 2 sin 30, you are getting Y, meaning you are converting R theta into XY, isn't it? You are converting a polar form into Cartesian form. So Cartesian, so you see what is the Cartesian form is the rectangular form, isn't it? So you say, what is the rectangular form of R theta? Then it will give you both X and Y at the same time. Are we together? So go to the calculator and press, what is the rectangular form of 2, 30 degrees? When R is 2 and theta is 30 degrees, what is the rectangular form? You will get the X component and Y component at the same time. Go there. Can you do that? Then you recall the way you recall. I've been shown you how to do that. So go to the rectangular form of your R is 2, shift to get your comma, or comma is not shifting this. Yes. 30, what do you have? Then you recall. So that is Y. So you see, it will give you the X value which you already found, then when you recall and you get Y. Are we together? Good. But you know, in real sense, you've written the formula, meaning the X component is F cos theta, the Y component is F sin theta. So you see, I don't expect this kind of things in your working. Are we together? I I don't expect you noting anywhere this is the rectangular form of r theta. That is not the procedure. The procedure of getting an x component is 4 times the cosine of the angle, isn't it? The procedure of getting y component is the 4 times the sine of. Are we together? That is the procedure. Then you go to the next, F2. F2 was 2 root 2 at what angle? At 45 degrees. So we have 2 root 2 acting at 45 degrees. So you see this is r theta, isn't it? But we want it to be xy. Are we together? So you are looking for what is the rectangular form of r theta. The rectangular form of r theta is xy. Rectangular or Cartesian form, isn't it? Are we together? The rectangular form of a polar gives you rectangular. Are we together? What is the rectangular form of r theta? You get xy. So can you put that? What is rectangular form of 2 root 2, 45 degrees? Give me the first value. What is x?
2.
X is 2. Then what is y? 2. Are we together? Move to the next one. The next force is 6 Newton, isn't it? It is acting at what angle? 60 degrees. So you are looking for what is the rectangular form of r theta. You get xy. What do you have to be x component? 3. Then what do you have to be y component? 5.1? 5.196. Are we together? Let us go to the last force. The last force is 8 acting at 120 degrees, isn't it? So you are looking for the rectangular form of 8, 120 degrees gives you xy. The rectangular form of r theta gives you xy, the x component and the y component, isn't it? What do you get to be the x component? The? Negative 4. And the y component? 6.928. Then now, the resultant x component is the parallelogram law. You use the parallelogram law, meaning you add all the x components. Are you seeing that? You use the parallelogram law. You add all the x components. So if you add all the x components, what do you get to be the resultant x component? 2.732. Then what do you get to be the resultant y component? You add all the y. 15.124, isn't it? So you found the resultant x component and you found the resultant y component. So after getting the resultant x component and the resultant y component, what do you now get? You now get the magnitude of this resultant, isn't it? So what is magnitude? Pythagoras theorem, meaning it is the square root of the x component squared plus the y component squared. Then you leave it like that. Then you go to the direction. What is the direction? The direction is given by the tan inverse of y over x, isn't it? Meaning tan inverse of f of y over tan inverse of f of x. The formula, writing the formula is what is important. Then the values you now substitute from the calculator. Are we together? Is that okay? So you go to the calculator. When you look for the magnitude and the direction, that is r theta, meaning you are looking for the polar form of this rectangular form, isn't it? So you are saying the polar form of xy is supposed to give you r theta, isn't it? The polar form of xy is supposed to give you r, meaning r theta is the polar form of xy. Are we together? R theta is the polar form of xy. So the polar form, your x component is what? 2.732, comma, your y component is what? 15.124. So when you look for this polar form, the calculator will give you the r and the theta value. Are we together? Meaning if you are using that right calculator, it will write for you that r is equals to this, and it will write for you that theta is equals to this, so that you don't make mistake. Because there are people who will come and start looking for a rectangular form of a rectangle. xy is already a rectangle. How are you now looking for this rectangular form again? Meaning you will get the same answers. Are you seeing? Are we together? Are we together? So from there, what do you have? What do you have to be the polar form of this?
15.6.
That is the magnitude, isn't it? So it means this magnitude is 15.39, meaning 37, isn't it? And the direction is 79 point. 0.76 degrees. So you see, when you are going manually, for the manualist, you are going to look for the square root of 2.73 squared plus square root 15.124 squared. This is what the manualists are going to do, isn't it? And when you do this as manual like this, you are going to get the same answer. Are we together? Then you are going to look for the tan inverse of f of y over f of x, 15.123 divided by this. There you are advantageous because both of them is positive, meaning they are in the first quadrant. So you will get it from the calculator direct. But there will come a situation when it will not be in the first quadrant. You will have to maneuver and try to check where is this resultant force. Is it in the second quadrant? Is it in the third quadrant? So you see all those steps are waste of time. But the calculator will give you the answer direct, isn't it? Are we together? Good. So you must always know the formula, then you use the direct means of getting the values of these formulas, isn't it? You don't go to the question paper and you start writing for us the magnitude, then you start coming with the things which are very weird like this. No, you don't do that. These are the formulas which are accepted. You see that? Yes. But now this is a means of getting these values. Are we together? Good. So that is how to handle such kind of problem.